Hey AP Psych students, today we're going to be looking at a few of the terms that maybe people get messed up a little bit with. There's obviously a lot of terms like that. Some of these are a little bit more obscure, but sometimes they've showed up on the AP exam. So we just want to make sure that we take a look at a few of these because you might not look at them yourself. So the first one here is standard deviation, and at its root, standard deviation is basically measuring how close together a set of data is or how spread apart it is. So if the standard deviation is pretty low, we're going to say that that set of data is pretty close together. So all the test scores were clumped really close together. If the standard deviation is really high, it means that they're all really spread out. Now, where we've seen this before is on a chart like this about a normal curve. We saw this with IQ. So in the middle here, we have this line here represents in a normal curve, the mean, the median, and the mode, all three. And then you can see 50% falls above that, 50% below that, and it's kind of divided up into these segments. You might remember that between the middle here and this line, we're going to say that's one standard deviation above or below. So for IQ, that amount was 15 points. It depends on the data set you're looking at. For IQ, it's 15. For other things, it might be 1 or 4 or whatever it might be. They'd have to tell you if it wasn't IQ. And so you can see this is one standard deviation below, one standard deviation above. Together, in a normal curve, 68.2% of the population falls within one standard deviation above and below the mean. So most of the scores, like for IQ, if we know that the standard deviation is 15 for that one, we know that, basically over 2/3 of the population fall between an IQ score of 85 and 115. It's about 95% within 2 above and below, and basically almost everyone within 3. So that's a little bit about standard deviation. I know it's not everything about standard deviation, but hopefully it helps refresh your memory. Okay, I already mentioned these terms, the mean, median, mode, also throughout range. Most of you are pretty confident with these, but they do show up, and a lot of times they just get called the measures of central tendency. So if you see that term, especially on FRQ number 2, measures of central tendency, don't get thrown off. They're just talking about mean, median, mode, range. That's what they're talking about. So again, the mean is the average, the median is the middle, the mode is most frequent, and the range talks about like what is the whole, what's the lowest score and the highest score, how many does that fit, is the large range, short, small range, etc. So don't get thrown off by measures of central tendency and think it's something you don't know, because you do know that one. Okay. Let's move into biology here a little bit. These terms agonists and antagonists. Whew, this one is something that's kind of scary for some students. So essentially, when we are talking about agonists and antagonists, we're talking about usually drugs or substances that are interfering with the normal action potential in that process where the neurotransmitters are shooting out the axon terminal and connecting with the synapse. So I always start with antagonists because I think that one's easier to understand. So in literature, an antagonist is someone who blocks the hero. It's like the villain. And in this sort of setup, the antagonist is a drug or a substance that's blocking the neurotransmitter from being able to connect. It's stopping the transmission. It's stopping, if we view our neurotransmitter as a hero, it's stopping that action from happening. The agonist is the opposite. So the agonist makes it more likely that the hero of our journey, the neurotransmitter, is able to connect and send a message onward. So antagonist blocks or stops in some sort of way. The agonist helps. Okay, moving forward here. Cerebral cortex. So when we were talking about the brain, we had all the different lobes. The frontal lobe, the parietal lobe, the occipital lobe, temporal lobes here on the side. Now, hopefully you're feeling confident with all of those lobes. And obviously sometimes they talk about this prefrontal cortex. We didn't talk a ton about that, but it's like the very front part of the frontal lobe. And as you get further forward, we're talking about things that make you even more human. So more executive functions, more high-level planning, thinking about the future, all that sort of stuff, prefrontal. So not even just frontal, prefrontal. All of them make up the cerebrum, which is like the part that looks like lobes, the part that sits on top of the limbic system. Limbic system is all those little bits in the middle, like the amygdala, hippocampus, hypothalamus, those sort of things. So they're all part of the cerebrum, and the cerebral cortex is the outside crust of that has all the gray matter, which allows for complex thinking. And there's part of the cerebral cortex in each one of those lobes. So it goes across all of it, all along the top, and is corticalized to make sure that there's lots of surface area. Okay, so another term, mirror neurons. We've mentioned this a couple times, but it's one that might show up. So talk about them as showing up in the premotor cortex, so kind of in the front of the motor cortex, which is in the frontal lobe, along the sides there. And you usually hear about these when we start talking about autism and empathy and social skills and all kinds of things like that. If mirror neurons are working correctly, basically neurotypical people tend to mimic what they see. They pick up things through observational learning. They just do it automatically. But if mirror neurons are not as prevalent or they're not working correctly, sometimes people really struggle with social skills. And that's one thing that we see in some cases of autism, especially as it becomes more and more pronounced. Okay, another one that people tend to mess up is something called the reticular formation. Now, I partially want to mention this because it goes by a few different names. Our book says reticular formation. Some books call it reticular activating system, or RAS. Some people use the acronym Rise and Shine because it's the sort of thing that makes you alert, makes you come alive. It deals with arousal. So if a deer runs out in front of your car, it's going to be the sort of thing that's like, whoa, I need to pay attention to this. So it's the exact same thing. So if you see it on the test, it deals with arousal, alertness, paying attention, same thing. So don't get thrown off by that one if you happen to see it. Okay, Gestalt. This one showed up, several of you mentioned this as not really knowing what it is when we did some of those early reviews. So Gestalt psychology typically is talked about in sensation and perception in that chapter. And it really deals with people that are looking at the whole as opposed to all the parts, and saying that the study of the whole is more important than the study of all the little things. So if you wanted to apply that to the sensation thing, they would say, to sensation or to biology, they would say, each one of these cells is super interesting, I guess, on its own, but even if I add up all those cells individually, it's just a bunch of cells. What I'm interested in is how all those cells come together to work as a system. The sum of it is more interesting than even if I added up all those individual cells on their own. So when talking about Gestalt psychology, a lot of times they're going to start looking at things like optical illusions and how we understand the world. Like I said, sensation perception. So for example, these are some Gestalt principles. Closure. So we like to fill the gaps. Symmetry. We like things to basically mirror each other. We like things to be closer together. We tend to group those. We tend to see things as continuous. I can't talk. Okay, and then similarity. We tend to lump things together in certain ways. So it's just how we understand things. So if you hear about Gestalt principles, they're talking about how do we group things, typically. Another term that shows up here, which threw some of you off when we talked about it in class, is figure ground perception. This is the idea that we can figure out which part of something we're looking at is the figure that we're focusing on and which part is the background. And we can flip those back and forth. Which thing is the background, which is the foreground. You might remember a picture of the vase that you could also see faces in, depending on if you looked at the black part or the white part. You can flip back and forth. Which thing is the figure, which thing is the ground or background. Okay. Let's talk about binocular and monocular cues for depth. Monocular means you can do it with one eye. And all of these are examples of things that you can tell just with one eye as far as depth. So linear perspective, you can see lines kind of converging as they become closer to a point. Interposition is something that's in front of something else. Height, so something that's higher up in your field of vision is probably further away. Texture, the more texture you can see, it's probably closer. Relative size, light and shadow help you understand that. So those are all monocular. Even with just one eye, you can tell all those things. So you can tell a lot about depth just with the one eye. But two eyes allows us to do a couple different things. One of those terms is retinal disparity. So you have two different eyes and they receive two slightly different pictures. Basically your brain automatically calculates how different are these pictures, and when things are more different between the two eyes, we view them as closer. So if I hold the finger in front of one eye, it's going to be very different from eye to eye, the picture of it, so we know it's pretty close. If the two pictures are pretty identical, we know it's further away because there's more room for it to adjust. The other one is convergence. The more that your eyes physically have to turn in to focus on an object, probably the closer that item is to your face. So there's just a couple terms to keep in mind. Okay, let's talk about the term heritability and heritable. So when we say that something is heritable, it means what is the extent to which the difference between individuals can be attributed to genes? Obviously, there's going to be some things that are going to be similar just because we're all human, but then there's differences. How much of those differences between us are attributable to genes? Some things are highly heritable, so height, very dependent on your genes. Like, it just is. If you have tall parents, you're probably more likely to be tall. If you have shorter parents, you're likely to be short. IQ is also highly heritable. Some disorders are more highly heritable, like bipolar disorder is more highly heritable. Some things are lower as far as heritability, so skin cancer has more to do with environment. Type 2 diabetes, more to do with environment. Not entirely, but more so. Okay, let's talk about another person that we didn't talk about as much in class, and he's now moving into the development section. I want to talk about a guy named Lev Vygotsky, and especially his term, the zone of proximal development. So Lev Vygotsky was really talking about how do kids learn how to do things, and he said that, kids can learn from basically anybody. Anybody can act as a teacher, anyone can act as a model. It could be an official teacher, it could be a parent, could be a friend, could be a YouTube video, could be lots of stuff. But what he says is that basically there's what you can already do. Let's look at this graphic here. What you can already do. You already have a certain skill. And he's going to say there's some things that you could do if you had help, and there's some things that are way beyond what you can do. So if you can add, you already feel pretty confident with adding. With help, you might be able to subtract. What you can't do is multiply yet. That's just too hard. You don't have that yet. So he's talking about the zone of proximal development is what can you do with help? And really talking about scaffolding or building step by step to get further and further with the help of a teacher or a model. A couple things here about gender roles, and then we'll wrap up this video pretty quick here. So when we talk about sex versus gender, sex is more biological. We're talking about chromosomes here. So XX is for girls, XY is for boys, males. That is pretty biological. It doesn't always match gender. Gender has to do more with gender roles. So we talk about social learning theory. What does it mean to be female? What does it mean to be male? How do we learn that from society? And gender schema. How do we think about gender? How do our views about gender and ourselves change? Now, for a lot of people, sex and gender go together, but sometimes they don't. And we talked a little bit about that earlier on in development, but just to kind of be clear on the differences between those two in general, at least. Okay, let's talk about feature detectors because I realize that's still in this segment. Okay, so feature detectors is a term that throws people off quite a bit. So if we are talking about vision, especially, you could have it in other senses, but it usually gets talked about in vision. A lot of times when you are trying to understand, you have all these colors coming into, all this light, all this color coming into your brain, but you have to try to figure out what's what. What's the lamp? What's the wall? What's the computer? What's, your friend? And basically there's neurons in the visual cortex that allow us to see what's happening together. So if someone's moving, we see it, it's basically just light, but we see it as all moving together. We see the edges and forms of that happening, and we see it as one solid image that's moving. So in our brain, we have neurons that help us see what's different from something else. And we do this all at once. We do this in parallel. So we parallel process vision, we parallel process music. We can hear music and also be talking to somebody and also be doing something else. But feature detectors help us figure out what's what. So for now, that's the first set. We're going to be moving into a review game. So go ahead and do that. And then we'll look at a few more terms.